Okay, all right, I'm going to go over this one. So I put the power reducing formula up there in case I need it. Oops, I forgot to write the other one in though. If you notice, the other one's the same for sine. It's just 1/2 minus cosine 2 theta over 2. Okay, so let's draw a little sketch of this graph so we have a general idea of what we're looking at. So when we're at 0 for theta, we're at 1 for r. When I'm at pi over 2, I'm going to be at -1. When I'm at pi, I'm going to be at 1. And when I'm at 3 pi over 2, the sign is -1. So this is going to be at 3. So I have a graph like this. My inner loop is going to come here. It's going to come out. Look something like that. So to figure out, I know that my integral is going to be the integral of 1/2 times 1 minus 2 sine theta squared. With respect to theta, I just got to figure out where my loop should go. So let's just set r equal to 0 and see what we get for theta. Oops, I forgot the 2 here. Sorry, sloppy. So subtract 1, get -1 over here, divide by -2. So I'm going to have 1/2 equals the sine of theta. So where is the sine of theta equal to 1/2? That's going to be here and here. So when theta equals pi over 6 and 5 pi over 6. So I know that as I'm moving around my curve, I'm starting when theta is 0. By the time I get to here at pi over 6, I'm already back at the origin. At pi, I'm down here. And at 5 pi over 6, I'm back. So I want to integrate from pi over 6 to 5 pi over 6. Or again, I could have integrated from pi over 6 to pi over 2 and doubled my answer. So either way is fine. Or I could have done pi over 6 to pi over 2 and doubled my answer. So either of these is fine. I'm going to go with this second one because I'm going to like how the 2 and the 1/2 cancels. I'm going to find that pi over 2 is going to be a lot easier to plug in. So I'm going to use this one. So let's square. I'm going to have the integral of 1 minus 4 sine theta plus 4 sine squared theta, pi over 6 to pi over 2. I'm going to move my work down here for a second. I have to replace this, so I'm going to have the integral of 1 minus 4 sine theta plus 4 times 1/2 minus cosine 2 theta over 2, using that power reducing identity. I'm going to clean this up some more. I'm going to have the integral of 1 minus 4 sine theta plus 2 minus 2 cosine 2 theta. And again, well, this is going to become 3, so I can integrate. So I'm going to have 3 theta minus, so the integral of sine isn't cosine, it's negative sines. This is going to become plus 4 cosine theta. And this is going to become plus 2. Whoops, wait, hold on. Sorry. I was getting ahead of myself in my mind. This is going to be minus 2 sine 2 theta divided by 2. And I'm integrating from pi over 6 to pi over 2. Okay, stuff is going to cancel. Let's see what happens. So I'm going to plug in pi over 2. So I'm going to have 3 pi over 2 plus 4 times the cosine of pi over 2, so plus 0, minus 2's cancel, sine of 2 pi over 2, which is the same thing as the sine of pi, which is 0, minus, plug in pi over 6. So 3 times pi over 6 plus the cosine of pi over 6, that puts me, it's here. This is going to be 4 times root 3 over 2 minus 2's cancel, sine of 2 times pi over 6. So really that's the sine of pi over 3. So minus root 3 over 2. So we have 3 pi over 2 minus pi over 2. I'm going to distribute this, and I know I should be able to do this in my head, but I don't want to right now because I'm afraid I'm going to mess it up. So this would reduce to a 2. So we're going to have minus 2 plus root 3 over 2. Whoops, minus 2 root 3. So if I want a final answer on this, I will have 3 pi over 2 minus pi over 2 is 2 over 2. So I'm going to have pi, and then 2 root 3 plus this is going to be minus 3 over 2 root 3. Maybe I'm right, maybe I'm wrong. Who knows? But that's what I have for that one. Let me give myself some spice. And let's look at this one. Show 2 ways to find the area in the second and third quadrant of this. So let's graph it. Let's draw it. So when I'm at 0, I'm at 6. When I'm at pi over 2, I'm at 3. When I'm at pi, I'm at 0. When I'm at 3 pi over 2, I'm at 3. So my graph goes like this. Show 2 ways to find the area in the second and third quadrants. So first of all, notice it's the same. So there's my easy way of showing this twice. So I can either do the integral of 1/2 r squared, and I can integrate from here to here. So that was from pi over 2 to 3 pi over 2. Or I can just go from pi over 2 to pi. And I can double my answer. Those are my 2 ways. Thank goodness we don't have to go and finish that one.